Hi, my name is Rajveer and welcome to Learn VFD in a Day sessions. Now, in this series of video, we are going to learn understanding drives, Allen Bradley, PowerFlex 4M. Alright, earlier we have done Delta Drive VFD in the course. Now it's all about Allen Bradley. Okay, so that's the drive in front of you. This is PowerFlex 4M Allen Bradley drive. Alright, and let's go step by step what we have in this course. And in this first video, we'll understand the various components of this drive and the wiring as well. Alright, so if you see this drive, let's move ahead. We are using this VFD PowerFlex 4M, which is 0.4 kilowatt. So that's the capacity. This is the capacity which is correlated with the motor capacity. Alright, if you're driving your motor having a rating of 0.5 HP, you should use this drive 0.4 kilowatt, which is equivalent to 0.5 HP. So it's very necessary that your motor ratings and your drive ratings should match. Alright, otherwise there's a confliction. You should not connect your drive having lesser rating than your motor. If your drive is having 1 HP rating and motor is 0.5 HP, still you can run your motor. That's safe, provided you have entered the parameters in the drive that you are running 0.5 HP motors. That is a provision for that. And this drive has input voltage of 230 volts, 1/3 phase, which means it can be given single phase or 3 phase input. Output is 230 volt 3 phase. Alright, that's the specification. And if you see this formula, it says motor direction proportional to frequency. Motor RPM is 120 F/P. That's the frequency component. So in 3-phase induction motor, if you want to change the speed, that's the formula we follow. So in which your frequency is directly related to your speed. So what we do is we use this drive to change the frequency. Alright, so if we change the frequency, speed will change automatically because this is the number of poles. It is difficult to change the poles. Earlier we used multiple poles drive, but it's not required now because we have provision to change the frequency. So that's a little bit about our drive which we are using. Alright, so now this drive has maximum operating range of 0 to 400 Hertz. So this is what this drive can output from the output terminals. Alright, so now let's see the status screen. Now you can see over here as well. Okay, this is the frequency, commanded frequency. This shows here. Okay, this shows what is the present frequency command on your drive. Alright, then you have motor run speed, run stop indication. That's the indication, and if you cannot see that clearly here, but it shows here right now motor is stop because this run LED is not on, so motor is stop. So when you press run from here, this will start the motor. You can see this LED here, and that's the frequency, command frequency 16.6. Alright, that's the direction. This is reverse. If it is reverse, this LED will be on. So let me show you. This is the reverse button. When you press this one, you see this is the reverse, and that's the forward which is blinking, which is getting off. So that's the reverse direction. If I press it again, it will toggle the direction and move to the forward. So motor will first go to 0, then it will move to forward. That's the forward direction. Then you have this parameter which says program. So when you program any parameter, like if I press this one, and if I go to, let's say P101, when I press enter, when I press enter again, hold on, let me go to 106. If I press enter and change the parameter, let's say I go for 08, which is my speed reference. Can you see this light? This shows that you are going to program the drive. So that's the program LED. If you want to program, this will show you a light. Alright, let's go back to default. And this LED over here, which you can see named as fault, this indicates when you have any fault in your drive. Alright, this LED will be on. And these are the keys to read and write the parameters. This is increment, decrement, enter, escape, this is select. Okay, 5 keys. Then you have one potentiometer to change the frequency, command frequency. You can change from here. Then you have start button, stop button, toggle directions. These are the indications. You can see in the slide voltage reading, ampere reading, and hertz reading. Right now the reading which is here, it is hertz, so that's why this hertz LED is on. If you want to see ampere, in that case ampere LED will be on, and so on. So that's the indication status screen. Alright, so now what we have inside. So if I open this cover from here, you will find few circuits. These are the different control terminals. This has been highlighted in the slide. So if you come here, it shows control terminals. These are the terminal by which you can turn on your drive from external source. You can turn it off. You can change the speed. You can give 0 to 10 volt input to rotate to change the frequency from external potentiometer, for example this one. This can be linked to the drive by connecting these wires to one of these terminals. Which are those terminals we'll discuss in the later slides. Alright, so you have here frequency feedback. In many drives you may find frequency feedback and analog current input 4 to 20 milliampere, which will change the frequency to 0 to 50 Hz or your maximum Hertz. Then analog voltage input 0 to 10 volt to change the frequency of the drive again. These are the control terminals. Alright, and this port over here, this is the RJ45 port, by which you can control your drive by Modbus applications using a PLC. Okay. Then you have motor output terminals. This is a 3-phase output terminals connected over there. You'll find at the bottom, which is going to the motor. So we have taken these terminals over here. So right now we are having a supply coming to these terminals. Okay. This can be connected to motors by these 3 plugs here. So we also have a motor here. This is a 3-phase motor, which can be connected to these 3 terminals. All right. And then we have 3-phase single phase. This is the input. This comes at the top over here. This is a single phase or 3-phase input, which can be connected to run your drive. In many cases we used to connect contactor at the top over here, but you can do that using MCB. So in our case I'm using an MCB to turn on the drive. Alright, so this was all about the wiring. So we'll discuss more about internal wiring. What are the different control terminals, what are the details of these terminals in the next video. Alright, thanks for now.